The Big Bang is a theory for the beginning of our universe. Discoveries in physics and astronomy in recent years have made scientists quite sure that our universe did in fact have a direct beginning. The Big Bang tries to explain our start, and is now the most accepted theory in modern science. The Big Bang occurred 13.7 to 14 billion years ago. The Big Bang was not an explosion, it was a sudden expansion. At the beginning, the universe was an infinitely compacted orb of all the energy in the universe. The orb was hundreds of times smaller than a pinhead, and it was denser and hotter than anything ever known to man. The universe was an active ball of energy. Suddenly, the universe expanded, and this theory states that it is in fact still expanding. Before the Big Bang there was nothing. The Big Bang happened in complete darkness, and it did not happen in space. This is because neither of these two even existed yet. When the orb expanded, there was a tremendous flash that left behind huge amounts of radiation. The universe quite literally inflated into existence. For some reason, the universe expanded from smaller than an atom to the size of an orange in no more than a trillionth of a second. Within 100 seconds, the universe was as big as our solar system. The first second of the universe was extremely busy, and one of the busiest seconds that the universe has ever had. During this second, the earliest elementary particles, known as quarks, were created. The universe underwent an extremely rapid exponential expansion known as cosmic inflation. The elementary particles just previously created became hot and dense quark plasma, sometimes known as the quark soup. This became distributed very thinly across the universe. Quarks created electrons and neutrinos. These three very early particles formed in large numbers as the universe cooled off to below 10 quadrillion degrees. Quarks annihilated each other upon contact, but in a process known as baryogenesis, they ultimately combined to form matter. The temperature of the universe cooled yet again to about 1 trillion degrees. This was cool enough to allow quarks to combine to form hadrons. These are similar to protons and neutrons. This process continued. After 3 minutes, the temperature of the universe fell to the point, about 1 billion degrees, where atomic nuclei could begin to form as protons and neutrons. This then combined to form nuclei of simple elements. These elements consisted of hydrogen, helium, and lithium. At this time, the universe was far more than double the size of our solar system. More elements would be created throughout time. Eventually, these elements would make light, the planets, stars, and everything else in the universe. 13.7 billion years later, and the universe is still expanding. There are many pieces of evidence for the Big Bang. 3 major pieces of evidence are redshift of galaxies, cosmic microwave background radiation, and the fact that we are looking back in time. Most galaxies appear to be moving away from us. This means that the light from them is stretched slightly and appears a bit redder than it would normally be. As an analogy, we can use sound. Imagine that a fire engine is driving past you with its siren on. When it is moving towards you, the siren is quite high-pitched. When it is moving away from you, the pitch drops and it sounds lower. With light, lower means more red and higher means more blue. You can see what this looks like in the diagram pictured. This diagram is of 2 galaxy light spectrums being compared. The redshift of galaxies proves the Big Bang by demonstrating that the universe is expanding and that stars and other galaxies are moving away from us. As the universe allows more space, the galaxies, stars, etc. will try to fill this space. This evidence primarily proves that the universe is expanding. The cosmic microwave background radiation, or CMB for short, is a faint glow of light that fills the universe. It is the residual heat of the Big Bang. The CMB is the oldest light that we can see, the farthest back both in time and space that we can look into. This light set out on its journey 14 billion years ago. Most of what we see every day is hydrogen. When hydrogen is heated up, it becomes hydrogen plasma. You cannot see light through hydrogen plasma, but you can see it through hydrogen gas. This is because it is transparent. At one of the points during the early stages of the Big Bang, our universe cooled enough for the hydrogen plasma to transition into hydrogen gas. Suddenly, we could see light. For the light to be seen, there needed to be expansion. This part of evidence through cosmic microwave background proves expansion once again. The Big Bang gave off lots of light. Using simple scientific laws, the light should still be there, travelling through space right now. The only thing that has happened while it has been travelling all of this time is that the universe has cooled and expanded. So it should look exactly like it did when it was emitted, only colder. The temperature of this light in all different directions should also be incredibly uniform, because it has spent exactly the same amount of time cooling. And it does look like this. Using a special type of thermal telescope called the radio telescope, scientists can see the cosmic microwave background. This allows us to see that the Big Bang itself did in fact occur. When you look out at the stars, galaxies, and our universe, you are actually looking into the past. This is because light takes time to get from here to there. The further away there is, the further in the past the light had to leave. And so we see all the planets, stars, galaxies, and so forth at some time in the past. Galaxies, planets, solar systems, and other things change over time. The main alternative theory to the Big Bang is called the steady state theory. In this theory, the universe does not change very much with time. Knowing that we look back in time, we can see the changing galaxies. We know that the universe has changed and has moved. This disproves the steady state theory. And it also supports the Big Bang by allowing us to see that the universe is not static. After all is said and done about the Big Bang, there is still one huge unanswered question. What started the Big Bang? This sets us off on a roller coaster of other questions. Are we the first in our universe? Is there some greater power? Is there aliens? We may never know the answer to these questions, but what we do know is how our universe came to be the universe that we know.
The Milky Way is home to many planets and stars. Earth belongs to the Milky Way. It's just one of the many galaxies in the universe. It takes 1,000 light years to reach from one side to the other of the spiral. Our solar system is approximately 25,000 light years away from the center of the Milky Way. We rotate around the center of the galaxy. We make a full rotation around the center once every 225 million years. The Milky Way formed approximately 13.6 billion years ago. When the Milky Way first started, it was just filled up with gas. For reasons unknown, the gas was able to form into clumps. These clumps had a gravitational pull which allowed them to be pulled to one another. This is how planets started forming in the Milky Way. Astronomers believe the Milky Way gained its size by consuming smaller galaxies. In fact, the Milky Way is still getting bigger and always will, as long as there is a galaxy small enough for it to consume. It's approximated the galaxy forms 7 planets a year. Our solar system is made up of 8 planets and 6 dwarf planets. NASA predicts that there are 173 moons altogether orbiting the planets of our solar system. All the planets that are in our solar system orbit the Sun, that makes up for 99.8% of the solar system's mass. There is an asteroid belt that runs between Mars and Jupiter. The mineral wealth of the asteroids in the belt are worth $100 million for every person on Earth. The Sun is the center of the solar system. The solar system is 4.6 billion years old. The 4 planets closest to the Sun, Mercury, Venus, Earth, and Mars, are called the terrestrial planets because they have solid, rocky surfaces. 2 of the outer planets beyond the orbit of Mars are Jupiter and Saturn. They are known as gas giants. The more distant planets, Uranus and Neptune, are called ice giants. Earth is the third planet from the Sun and the 5th largest planet in our solar system. Earth is still believed to have formed when our solar system formed 4.6 billion years ago. A supernova is believed to have exploded, putting out lots of gas. The gas started forming in clumps, and they eventually got to a size that was suitable and able to suck in small clumps with its gravitational pull. It's not known how the Earth was able to go from the rocky planet it was into the planet we live on today. Earth orbits the Sun and makes a full orbit once every 365.25 days, which is why there is an extra day in the year every 4 years, which is also known as a leap year. Earth orbits the Sun at 108,000 kilometers an hour, and Earth is on a 23-degree tilt, which is why the northern hemisphere and the southern hemisphere experience different seasons at different times. Oeg's object is a galaxy discovered in the 1950s by Arthur Hoag. It is a galaxy that is home to 8 billion stars. Hoag's object is known as a peculiar galaxy, which means that it is unusual in its size, shape, and composition. It's estimated to be about 1,000 light years wide and is about 600 million years from Earth. How Hoag's object is formed is still a mystery. Hypotheses include a galaxy collision billions of years ago and the gravitational effect of a central bar that has since vanished. Nebula is a bundle of gas that clumps together that forms a star. It is formed when portions of the interstellar medium collapse and clump together due to gravitational attraction of the particles that comprise them. Interstellar medium is the matter that exists in the space between the star systems in a galaxy. All stars start from nebula. Once it gets big enough, it will start collapsing under its own gravity. As a result, the increased pressure in the core triggers nuclear fusion of hydrogen into helium, and the star is officially born. The size of a star at this point will set the course of the rest of its life. A star with a solar mass between 0.5 to 8 is considered an average star. A massive star is a star with a mass 8 times the greater of the Sun. It is difficult for stars to get this large, as a number of factors influence stellar development, and these factors often limit size. But scientists have been able to study planets up to 150 times the mass of the Sun. A red giant star is a darling star in the last stages of stellar evolution. In only a few billion years, our own star will turn into a red giant star, expand and engulf the inner planets, possibly even Earth. Red giant stars reach sizes of 100 million to 1 billion kilometers in diameter, 100 to 1,000 times the size of the Sun. During this stage of its life, the red star is starting to collapse under its own gravity. Red supergiants are supergiant stars that are the largest stars in the universe in terms of physical size, although they are not the most massive. The radius of most red giants is between 200 and 800 times that of the Sun, which is still enough to reach from the Sun to Earth and beyond. An average star goes into a red giant star as a massive star goes into a red supergiant. Planetary nebula is made up of ionized gas ejected from a red giant star. The gas from the star starts moving away when its core can no longer support itself with fusion reaction in its core, so gas starts to sweep away. A supernova is when a red supergiant star explodes. When they explode, they produce enough light to outshine an entire galaxy, but only for a quick amount of time, to never be seen again. A supernova occurs when a red supergiant starts collapsing under its own gravity. Because it happens so quickly, scientists struggle to really study them, as they are never to be seen again after the flash light. A neutron star is the smallest possible type of star known. They are as little as 12 to 13 kilometers in radius. Although they are this small, they are one of the most densest stars, as they can have a mass that of a few times our Sun's mass. It happens when there is no more energy to burn in a star, so all the atoms fuse together to make neutrons, and they fill the smallest possible space and make a neutron star. A black hole is matter, 10 times the size of the sun, packed into a sphere about the size of New York City. A black hole's gravitational pull is so strong that not even light can get away. Most black holes form from the remnants of a large star that dies in a supernova explosion. Smaller stars become dense neutron stars, which are not massive enough to trap light. A white dwarf star is the last stage for a low-medium mass star. White dwarf contains the mass of the Sun in the size of Earth. Unlike a neutron star, white dwarf stars are electron-filled. After a red giant star loses its outer layers, forming a planetary nebula, the core that is left behind is a white dwarf star.
How life began on Earth. Life began on Earth from the most simple microbes and evolved into the most dazzling array of complexity over time. There are multiple theories on how the human race and how life came to be on Earth roughly 3.5 billion years ago. One piece of evidence that the timeline is somewhat right is the rocks in Greenland that are over 3.5 billion years old. They contain the chemical fingerprints of ancient bacteria and microbes. The rocks underwent a process analysing its chemical composition, looking for carbon, a signature for life. This test came out positive, however this does not point to any particular theory on how life came to be on Earth. Theories arise all the time about how life began on Earth and how humans came to be. Some scientists say that humans may have even come from Mars. Another theory is abiogenesis, a theory about life being created out of non-living things. However, one of the most believable theories is panspermia. Roughly 3.5 billion years ago, Earth was a hostile place, which was unfit for microbes that create life to arise on Earth. So scientists have then pointed to the life-creating microbes and bacteria to come from space, an environment that is rich in organic compound capable of creating life. Evidence of this is the meteorite that landed in Australia in the 1960s. It contained amino acids. It also contained the organic compound of carbon. So the theory of panspermia is that organic matter, such as amino acids or carbon, come to Earth from space dust or comets to create life. How humans came to be. Charles Darwin's theory is a world-famous theory on how humankind evolved on Earth. It is supported by many modern-day scientists. Darwin's theories of natural selection and sexual selection apply to human life as they do any other species. Darwin proposes that there were tiny changes over millions of years to the human race. He proposes that humans and apes derive from an ape-like ancestor that lived on Earth a few million years ago. The theory states that man, through a combination of environmental and genetic factors, emerged over time to evolve into humans and modern-day apes. However, modern-day apes evolved on a different evolutionary pathway. These three skulls are of the three main primates that may have evolved over time to evolve into humans. Even for billions of years to come, humans will slowly evolve and adapt to the changing conditions of Earth to better the species.